I was trying to figure out the SPSS stuff on here. Have you messed with that part of the software for this assignment?
No, most of the stuff that I open up, I just can't get to work on my Chromebook.
So
It just like open it for some reason.
doesn't like it, huh?
Yeah,
Well, that's no bueno.
yeah, yeah. This time didn't take too long. It was kind of an easier assignment. I was kind of happy about that.
Yeah. Guess we'll let everybody come along here. Yeah. What do you need? Factory assembly times. That's what we're doing for the.
Maybe I just want Ninja Arrow.
You'll get them eventually.
Hey, Austin.
Hey.
How you doing tonight?
Pretty good. Just got done taking an exam and finishing up reading up this section.
Sweet. Yeah, I was doing the same, minus the exam.
I feel like this whole section's like a rehash of the last section with like a slight twist to it.
With one extra variable, or yeah.
Yeah, you're just calculating the differences among the two.
Yep.
Instead of, well, calculate the differences in the two numbers and then the differences in all of them to find the deviation.
Right.
So it's really not that complex.
Yeah, it didn't seem to be too terrible. Are the Jareds coming along tonight?
Jared should be.
Okay.
I don't see why he wouldn't. Let me give him a call.
All right. Oh man, excuse me.
Austin, I just went 710 meters. Austin, 710
Hey, good. Just seeing if you were going to join us tonight. Okay. We're all on the... Yeah. So, do you want to resend an invite out to Jared?
Sure.
Okay. Cool. Yeah. We'll probably get started once you're in. Okay. Bye. Yeah, he just said he's looking for the call and didn't see anything. So
Oh, okay. Is his icon or
SpongeBob,
yeah,
Patrick.
massive SpongeBob? All right, sounds good. Just checking.
Yep.
Nothing wrong with that. No judgments here. Oh, there he is. Oh, man.
Hey.
Hey, Jared.
Thanks for the invite.
Sure.
Okay,
My pleasure.
are we all ready then?
Yeah, so should we jump into it?
Yeah, why not?
So, part one, what does it mean to have matched pair data? Well, from the video, the answer, the definition I liked was one sample is used to determine the other sample, or they can use
They're dependent.
two individual, yeah, dependent on each other like that.
Are we? Yeah, we are recording.
Yeah, we're recording here. Can you guys tell on your end that you're recording?
Yeah, it says live up in the top corner.
Sweet. Okay, good. That way you guys can keep me honest. Like it. Does anybody have anything they wanted to add to question one?
No.
Let's see. I guess you're comparing differences of the pairs instead of like just differences among the data.
Yeah.
So that's the only thing I can think of.
Okay. Yeah, that makes sense. Who wants to? Sorry. Oh.
What are the differences in this hypothesis test between a one sample T and a match paired? I guess the hypothesis are still going to be like, still going to have your hypothesis test. So is it talking about like the p-values and t-values?
I think it's talking about the three.
The statements?
Yeah, the statements. So either is not equal to, or is less than, or greater than.
Okay. Yeah. So yeah, I feel like it's just gonna. That's all I thought initially, unless it was addressing p-values. But just the statements they're pretty much the same.
Yeah, I think the only difference in the statements is on the paired sample you're doing greater than or less than 0, whereas in the one sample you're doing greater than or less than isn't it the mean, the sample mean?
Also, isn't in the match pairs you know the standard deviation, don't you, as opposed to the other one?
You can have an unknown.
Yeah, you could have either way. I think.
Can't have an S value. Right?
I think so. I bet our Thursday lesson will be working with an unknown on the matched pairs. Okay. Part 2.
I'll read it.
Okay.
So a matched pair T procedure. A manager at a factory feels that the amount of time that his workers spend doing the part on the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and used the level of significance of 0.05. So let's go Green Honey and download this thing. This for downloading factory assembly times.
Are you done on that now?
Yeah, almost there.
Okay.
Okay, got it. So what is the research question? So he wants to know if the mean wait time is different than what it was before, or like the mean time it takes to complete 100 products in 9 minutes. So the answer says after implementing the new loading and loading procedure, it is the mean wait time different than the wait time before? Yeah. And then state the null and alternative hypothesis. So the null is UD equal to 0. The alternative is UD is not equal to 0.
Okay. All right. Austin, do you want to do number 2?
Sure. Collect the data. So describe the data collection procedure. So we took 9 workers and measured just the amount of time that it took for them to complete 100 products.
Mm-hmm.
And so I guess considered a convenience sampling, right?
Mm-hmm.
Yeah, probably so.
I mean, I don't think that's, looking at the thing, it doesn't say that was important to address, but sounds like if they were to ask us, it would be a convenience. The answer says the researcher collected assembly times in minutes from the 9 factory workers before the change, and collected the assembly times of the same workers after the change in procedure. So that's where you get the 2 pairs from.
But isn't one of the assumptions of this being correct that it has to be a random sample? Seems like I remember that.
Well, maybe it's ideally, I guess.
9 random workers.
Yeah.
Of your convenient population.
But Austin, you're absolutely right that they don't specify whether it is a random sample or not.
Mm-hmm. Yeah.
So the assumption could be that it's a convenient sample. He just pulled the first 9 dudes he found.
They took their 9 slowest employees.
The 9 worst employees.
And compared them against the 9 fastest.
Which 9 employees do I want to fire?
I mean, if you were wanting to see how, actually, I guess you'd want it still random. I was gonna say, if you wanted to see how effective the change was, you would probably want to do it on the worst and then as well the fastest.
Probably so, yeah. You may want to.
Or if it was for
or if it's random, then it's, I guess, better because we can calculate it.
Right.
If it isn't random, then it's definitely not doing those workers any good if they don't speed things up.
Yeah, for sure. Okay. Let's see. Number 3. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. Okay. Sorry, go ahead.
I think I downloaded the right, because I just clicked on the link on the attached, like the paper, the assignment.
Yeah.
They got the right data. I'm not sure though. But my chart and kind of what I just see is that most of the time there is a difference, but sometimes there's not a significant amount of it. So like sometimes it is faster, like the newer way of doing it, and sometimes it's slower. So it's not really consistent with it, but there's a difference constantly.
When you say the new, oh yeah, okay, I see what you're saying. The new implemented methodology.
Yeah.
So what software did you use to input the data?
Excel.
You used the Excel. Did you use the pair sample t-test?
Probably not, because that doesn't sound familiar.
So I just opened the quantitative inference procedure, and the second tab is the paired sample t-test. That's the second tab over. It's the same Excel spreadsheet we were using last week.
Oh, gotcha.
But it's the second tab.
Gotcha.
Is anybody else using that, or are they using a different?
That's what I've been using.
Okay, so then you just go and you key it, or you import the data, and so the number is 9. Hold on a sec. What is that value that's 1 minus the number? It's slipping my mind right now.
That's
the freedom,
the DF, the freedom, degrees of freedom.
Thank you, degrees of freedom. So the degrees of freedom is 8.
Mm-hmm.
I'm not exactly sure. I guess the histogram goes in here, but I didn't see a histogram on that Excel spreadsheet. Is that somewhere else?
That's the SPSF.
Yeah.
Thing.
Okay.
SPSS.
All right. So when I plugged it into SPSS, see if my histogram looks the same. And of course I forgot that. So in SPSS, it's analyze, is it descriptive statistics, and explore? Histogram, there we go. There we go. Now I have a histogram which looks totally different. Awesome. Mine does not look like a middle finger. Okay. So does anybody want to add anything to 3, or should we go on and see what else it's asking us?
No, I think we got what we need.
All right.
So number 4.
Yeah.
What type of hypothesis test is appropriate? So a two-tailed one. B, what are the requirements for this test? So it has to have a normal distribution to be able to detect like the calculator with it. Compute the differences between the 2 times and determine if the requirements are met for this test on your answer. The answer sheet says, we assume a simple random sample of the population. N is less than 30, so we would need to make a QQ plot in order to test the normality of the data. The differences are not very normally distributed, so the requirement is not met.
Okay.
Yeah, that Q to Q plot doesn't even look very good.
Yeah. Yeah, they're kind of just all over the place. Continue. This is what you found part C. Compute the test statistic. So T was, it's either 1.22 or negative 1.22. And then degrees of freedom, like you already said, Ian's 8. Compute the p-value to the alpha level. So this one I didn't actually, the answer sheet says it's 0.257 because I didn't have the right data, I guess. So, because I got something in the negatives, didn't make sense. So it's greater than level significance. That means you're going to fail to reject the null hypothesis. Present your conclusions in the form of English statement. There's insufficient evidence to reject the null hypothesis, or English. Start to, let's see, to say that the time to make 100 products is any different after the implementation of the new assembly procedure. Rather than test the hypothesis, now say you just want to estimate the mean difference between the wait times and 95% level. What would you do? Do it and paste your results below. So it says create a 95% confidence interval using the T distribution. So have that.
So on the answer sheet, you can plot it either way, or why does it come up with two different
Yeah, I don't know.
I think it depends
confidence
on.
intervals?
I think it depends on, like, when you input the data,
Uh-huh.
you can say variable 1 minus variable 2 and get the difference that way, or
You're right.
you can say variable 2 minus variable 1.
Yeah. Okay.
It's because of our statements greater than or it's like not equal to, right?
No, here I'll show you my screen, and this should make a lot more sense. Let me see it. Okay, so here's our difference.
Yeah.
And you input the data, and the difference in saying this minus this equals this.
Mm-hmm.
But you could have also said this minus this equals that. You could do it backwards. So you could get a positive mean or a negative mean just by the way you find the differences.
Okay.
But doesn't that mean that one variable is not dependent on the other?
What?
Doesn't that mean that one variable, the second variable wouldn't be dependent on the first variable then if you flipped it? So like if you were to minus the second one from the first one? Those were the criteria, I thought.
I don't know. I just know that, either way, you do get the same difference.
Yeah. I see how we'll get a flipped number.
I think it's just easier to work with positive numbers. So if I came out with a negative, I would just make it positive.
Well, but both of the answers, one of them is a negative value.
Yeah.
So either it's a -3 or it's a -0.9.
Yeah, it doesn't matter either way.
Yeah.
Because we have a positive and a negative t value.
Yeah. So since 0 is in the middle of those numbers, then that would be a reason to reject the null hypothesis, because our 0 is in the middle of our confidence interval, right?
Mm-hmm.
So are we ready for number 5?
Yeah.
I could read that.
Okay, go ahead.
Okay. Next turn.
In a short paragraph, describe the action you feel should be taken based on the statistical results above. So, based on what we found, nothing should be changed. From the new system doesn't work, basically. The answer it gives here is you should describe how they need to find another way to reduce the time because this particular plan didn't make a statistically significant difference.
Okay.
Yeah.
Cool.
All right. Should we take a peek at the quiz? Is there any file we need to open up first? No, it doesn't look like it.
I don't see anything so far.
Okay, everybody got it open?
Yep.
So suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is H equals the mean of D equals 0. The alternative hypothesis is H is not equal to 0. And the population standard deviation is not known. Jordan collects. What's that?
There you go. You can do it with it and not having it known, like we were talking about earlier.
Right. Yeah. There we go. Jordan collects a sample size of n equals 9 and computes the d bar at 2.2 and the deviation of the sample at 3.3. What is the value of the test statistic? Let's see.
Just with these numbers, it looks like there's only one calculation we can make.
So the value.
So I'm getting 2.000.
Okay. So you're using the formula d bar plus or minus t times sd over the square root of n?
I don't know if this is right, but I'm just using the Excel spreadsheet and just typing in the numbers.
Oh, that's an even better idea. I like the way you're thinking.
Easy peasy.
Deviation 2.2. 3.3. Because we got the sample mean, then, or the S is the standard deviation, right? But the sample standard deviation.
Yeah.
Right.
D is the mean.
Yeah.
D bar is the mean of the data points.
Yeah.
Yep.
And d bar is the mean.
Hypothesis 0.
Oh. Right.
So then we're looking for just the t value, right?
Mm-hmm.
Which is, yeah, 2.0. Yeah. How many decimals do you think we should put?
I'm just going to put 2. Just the number 2.
Oh. Yeah, it doesn't say, does it? As far as decimal places.
Kind of annoying.
It is a bit. Okay, so we're all going with 2.
Mm-hmm.
The probability of being greater than 2. Doesn't that give you the answer? Okay, the
Is that
probability of being greater than
Is
2
that
is,
still talking about the previous question?
I think so.
Because
Use A to determine the p-value for the test. So we want it to be greater than. We want the type of test is greater than.
Greater than 2?
Yeah.
Just seems so weird. 0.040.
That's what I got too. But where do you put the probability? Okay, so
I don't know. Maybe is that?
How are you guys doing this?
Oh, you know what? The probability is that's the p-value right there. 0.0403.
I mean, that's what I would thought. I
So
mean,
that's
is
saying
that it?
if it's greater than 2, the p-value is this. How to determine the p-value for this test? What is it asking for? It doesn't even have a question.
use HA. Where?
so that,
The alternative hypothesis
Yeah.
to determine the p-value for this test.
Which is, oh, it's just saying use not equal to. So the probability for it to be greater than would be 0.0403. The alternative hypothesis, it's asking for the p-value of the alternative, which is not equal to.
So, do we use the Haplet thing to do that?
No, you just need to look at the p-value.
But the p-value is 0.040. Is that right?
That's for if it's greater than. It already gives us that. It says the probability for it being greater is 0.04, which is the p-value, and then it's asking use the alternative hypothesis, which is not equal to.
Oh, so but the not equal to is two-tailed. So we want it to be not equal to. Oh, so the p-value is going to be 0.080.
Yeah, because I don't know why the first part even exists.
It's a poorly worded question.
Yeah, it's very poorly worded. It gives you random information and then asks you for something else.
All right, so what it's saying is if the p-value for greater than is 0.0403, what's the p-value if it's not?
Yeah.
Which would be double that p-value, correct?
Yes, because it's a double.
Oh, because it's one-sided and not double.
Yeah, and so we got a two-tailed problem. Is that right? So we're at 0.080?
Technically,
I did 0.01 because my value came out to 0.05, so I rounded up.
You did what? I'm sorry, you did what?
When my value came out to 0.0805, and so I rounded to 0.81.
Yeah.
Oh, yeah, I did, yeah, you're right.
Okay. Use the data file in chapter 5. Wait, what? Oh, 12. Yeah, it's fine. Is that referring to the factory stuff or one of the other book datas?
Where's data A? So I have chapter 12 open. Let me see what the data A looks like.
Oh, it's specifically called Chapter 12 Data A. I'm downloading it.
Oh yeah, right there.
That's weird.
It'd be nice if they put all this stuff.
Oh. Does yours say data A1? Yeah, yeah, that's the file name. Okay. Okay. So then once we have it loaded into SPSS, we go Analyze, Descriptive Statistics, Explore. You load both lists, right?
Oh, we're gonna need B as well, so
Say that again.
heads up. We're gonna need sample or file data B as well, so.
Oh, you do?
Oh yeah.
Yeah, later on.
Oh, okay.
Okay, what did you guys get for your differences?
For the D bar, I got 31.025.
For the, isn't D bar the mean?
The mean of the differences.
Okay, the differences?
Mm-hmm. That D bar isn't. I think that is the mean of the differences, right?
It probably is. I thought it may have meant something else.
Yeah, that's what it is. Yeah.
Okay. So the mean of the differences is 31.025.
Yeah. That's what I got. And then for the standard deviation of the differences, I got 341.157.
Okay.
What was it you got for 5 again?
31.025.
Okay.
I think I'm loading this up wrong. Sorry, can we back up a step?
Mm-hmm.
Okay, so when I load this up, I have the date up there. I have a column of group 1 and a column of group 2. And then I'm going to explore, right?
Oh, I'm just using Excel.
Me
Oh,
too.
you're just, oh, all right.
That's why.
I haven't even
All right.
bothered trying to understand SPSS.
Sounds good. I like that idea better.
I like how they give us a system to use that we'll never be able to use again. Never will use again. If we are going to become like statisticians, or whatever they're called.
Well, you'll be able to log into this this online computer somewhere and calculate your stuff.
Okay.
Okay, so we're back to 7, the test statistic.
Sure. Is everyone okay with the answer I said for number 6?
341.157.
Yeah.
Sure. I don't have it quite loaded up yet, but Austin, I think that's you got the same number, didn't you?
Yeah, I got the same number as him.
Okay.
Okay. The test statistic I got 0.407.
That's how I got as well.
Okay.
And then the p-value is 0.689.
0.689.
Okay.
Okay. So we would fail to reject the null.
Because it's bigger than 0.5 or 0.05.
Yep. And then when you say the alternative is greater than instead of not equal to, you still fail to reject the null.
Yeah.
You still fail, yeah, because that comes out to be just barely less than the first one.
Yeah. It's like half of that, but still more than 0.05.
Mm-hmm.
Okay.
Now we need to be.
So then I got the next one loaded up. This data comes from nosocomial infections,
Uh-oh.
which I think is 2 words. That's 1 word. Nosocomial infection.
I think nosocomial is one word.
Yeah, but in here it just doesn't have a space there.
Oh,
And the I is capitalized. I guess that, yeah.
I see.
The null hypothesis, which is greater N or DF.
Okay.
This is kind of a weird question.
Oh, yeah.
Because it's really, like, if you remember what DF stands for, which is 1 less than the sample.
Yeah, that's right.
So, obviously, the sample is going to be 1 more than DF.
I didn't need to look
Yeah.
at those numbers.
DF is just the degree of freedom, correct?
Yeah, it's 1 minus, or the sample minus 1.
Yeah. So the answer is N.
Yeah, it's kind of like
Okay.
one of those recap questions, maybe.
Yeah. Okay, so I got to change my confidence level to 0.99. The null hypothesis is not equal to. The p-value. My p-value is 0.001. Is that close?
Yep.
Nice. Okay. So we would reject the null hypothesis on this one, right?
Greater
When you
than?
change the alternative. Oh, are you saying number 13?
I'm answering
No.
number 13.
You fail to reject because it's still not less than 0.01. So you would, yeah.
Yeah, it's 0.001.
Yep.
Okay.
So the next question is always one that kind of trips me up.
Yeah, so now we're doing greater than.
Yes.
Okay.
Mhm.
And I think it's because I keep thinking this in, like, if it's a level of significance, so the number decreases.
Mhm.
But does that mean it's more significant now or less significant? I mean, or
Did your p-value changed?
Yeah.
Yes.
Oh yeah, it does. Okay. I just didn't have enough decimal spaces out there. The p-value does it decrease? Wait.
Yeah. No, it should
It goes
decrease.
down by a whole tenth of a.
Yep. Yeah, it decreases.
Yeah, so it decreases.
Okay.
But the level of significance is more significant now, though. Right?
Right.
That's what always like messes me up. Is I think the number decreases, but it becomes more significant. So
It just helps us reject the null that much easier.
yeah.
So we're still going to reject the null on 15, right?
Yep.
These
Okay.
studies are really pathetic. Both of them are like, we failed and we failed again. The other one's like, rejected, and then they try something different and reject it again.
Well,
Couldn't even spell nosocomial infection.
But actually, the first one we failed to reject. So the second one was more effective than the first one.
Well, but the second one, it was like, you failed to reject it, and then it was like, well, let's try this other hypothesis, and we failed to reject it again. So they just, yeah.
Wait. Are you saying that number 13 you failed to reject the null hypothesis, or you reject it?
Number 9 and 10, we failed.
Okay. I got you. Okay. And then 13 and 15 we did reject the null.
Yes.
Okay.
Okay. Who wants to take next one?
I'll take it.
Okay.
As we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think a general rule can be made? Which alternative hypothesis will give the smallest p-value? It seems like whenever we change it from not equal to greater than, it's always smaller. But let's see what happens to less than.
Greater than looks like it was smallest.
Yeah, less than is the opposite of the greater than.
Yep, so greater than would be the smallest.
Okay. Greater than. Interesting. Wonder why that is. Okay, 17 is determine the 95% confidence interval for the mean difference between the two groups. What is the lower bound and the upper bound? That's 17 and 18. So we change that to 0.95. So I have a lower bound of 5.303.
Oh, upper bound. Oh, oops, I typed them both in there.
And I have an upper bound of 18.607.
That's what I have.
Okay.
Me too.
Okay. So 5.303 for the first one. And what did I say? 18.607. Okay. You want to submit?
Oh, 16. There's not enough information, actually.
Hmm. I suppose it does depend on the study then.
So yeah, I guess it would depend on where it lands.
Well, it depends on your data, what you're collecting.
Yeah.
I mean, what if you just randomly sampled a bunch of people with colds and we're comparing it to the normal temperature of the human body?
Yeah.
And, you know, you'd be statistically greater, or your less than would probably be greater probability.
Yeah.
Or, you know, if you actually, well, that doesn't really support my answer, but if you went and sampled a bunch of people with fevers, then yeah, it would be less than a greater than. But anyways,
I misread that question. I thought it meant in this setting. I didn't see the part that says the general rule.
Yeah, we should have thought that one.
That's why I thought, yeah, in our data it was like that.
sneaky.
All right. Well, thanks, gentlemen.
Yeah.
You guys have a good night.
You too.
Yep.
See you next time.
Okay.
It's
Send me your
Thursday.
stuff. Okay.